Hello. Today we're going to do just a quick review on some very specific sections in our book, section 7.1 through 7.4, and this is big ideas. My kids have a test coming up, and I said I would do a quick little review video with them. I have these awesome holographic ears on, but they also match the Disney Spirit jersey, so it has Disney in the black and silver. They match. They're amazing. I also have Vans that match these. It's just pretty cool. So anyways, so I'm just going to review, not necessarily really going to do many problems, but just kind of a quick review for my kids to remind them what to study. So first up, it's my pooch. Okay, first up, remember polynomials. Polynomial is the big family. And underneath polynomials, you have things like monomial, binomial, trinomial, defined by the numbers of terms. So monomial is one term, binomial is two terms, trinomial is three terms. Anything after that, there's no specific name, although kids in the past generally call a four-term polynomial quadnomial, whatever, but there's just no real specific names. Also, we talked about the degree of a monomial and the degree of a polynomial. Degree of a monomial is the sum of all the exponents in one term. Now, the exponents, remember, go strictly to the variables. And the degree of a polynomial is the highest degree of its terms. So you are looking for the highest exponent in the terms within your polynomial, and that would be the degree of the whole thing. So really just look for the highest exponent, and you're good to go. Standard form, make sure your exponents, highest on the left, decreasing all the way down to the lowest on the right. So it always has to be in order from highest power down to least power. That's why your constant is always on the end, because technically your constant has zero power because there's no variables. I mean, technically you could put like 16x to the 0, but x to the 0 is 1. So you still end up with 16. So just make sure those are in order. What else do we talk about? Degrees, your definitions. I think that's it for that. I mean, that was mainly 7.1. 7.2 was adding and subtracting polynomials. And so I'm going to do a couple problems. So for my kids, if you want to write this down, that's fine. 7.1, I just reviewed all the vocab and putting things in standard form and identifying the degree. So when you add polynomials, I call it stack your chips. Meaning you are going to stack like terms. You're going to stack your cubic terms with your cubic terms, your square terms with square terms, your linear terms with your linear terms, something like that. And you always want to make sure that they're in standard form when you stack them. So for example, I will do a problem. If we have like 3g to the fourth plus 2g squared minus 7, and we're going to add that to the quantity, 7g to the fifth plus 3g cubed plus, oops, I'm running out of room, minus 4g squared plus 5. So we're going to add this three-term polynomial. Technically, this would be a trinomial. The degree of this polynomial would be the degree of 4, so it would be a fourth degree polynomial. And we can't do a degree of monomial because we have more than one term. Over here, we have 4 terms as well. And so when I add these together, I'm going to stack them. I'm going to stack like terms. But notice, this polynomial is in standard form, and this one is in standard form as well. However, this has a term with a degree of 5. So we're going to put that out. So when you stack it, you want to have a space here. And I'm going to show you that in a second. So we have 3g to the fourth. You do not have a cubic term. So you could do one of two things. You can leave that as a 0, or you could put that in as like 0g to the third. A lot of my kids just leave it blank, but whatever. Is make sure, as long as you know you can't add that with something else. And again, I went from my quadratic term to my linear term. Sorry, to my constant term with no linear term. So you'd want to fill that in with like a plus OG. Technically it's 0g. And then a minus 7. These guys, you can just leave them as blank. So now when we stack our chips here, since we're adding, we're going to put 7g to the fifth out here because you can't combine that with a fourth term. And then plus 3g to the third and then minus 4g to the second, and then plus 5. I'll stab myself there. So on the top polynomial, I added in the O's, the 0 term, basically. Down here, I just left them blank. You can do both. You can do one or the other. It doesn't matter. I'm not that picky. And so you're going to combine your like terms. So we have 7g to the 5th. This can't be added with anything, so I'm just going to bring that down, plus 3g to the 4th. And we're adding, because remember, there's no sign there. It's positive. So 0 plus 3 is a plus 3g cubed. 2 minus 4, negative 2g squared. Bring this guy down. Plus 0g. And then negative 7 plus 5 is a negative 2. On this term, since we technically don't have it, you actually do not need to fill this guy in, because there was no linear term in this polynomial, and there was no linear term here. So we technically don't have to fill this guy in as our answer. If you had it in there, that's fine. You would still get the same thing. It's still correct. There you go. So that's stacking your chips. Now, when you subtract, it's a little bit different because you have to watch your signs. Because if you're subtracting a whole quantity, remember that you are subtracting, you're subtracting each term within that polynomial. So when you subtract each term, you're technically taking the opposite of the signs. I just tell my kids that you're distributing that negative 1. So let's go, 5e squared plus, 3e minus 4. And we're going to subtract 2e squared minus 6e plus 12. Something like that. So here, if you distribute this negative, you don't have to worry about your signs for when you're stacking. I like to do that because remember, you're taking this and you're subtracting this term and you're subtracting that term and you're subtracting that term. So that's why you end up taking the opposite. So I'm going to change those signs already. So when I stack them, I don't have to worry about my signs. So I'm going to stack this, and I'm just going to put that underneath it. Now remember, when I stack, I'm not necessarily adding or subtracting that polynomial. I'm just looking to the left for my signs. So 5e squared plus 3e minus 4. And now I'm just going to stack these under its like term. When I say stack chips, I was talking about, when I introduced this, I was talking about you want to put their baking chips. Not necessarily potato chips, but you put your milk chocolate with your milk chocolate. You put your butterscotch with your butterscotch, your white chocolate with white chocolate. So that's what I'm talking about when I say stacking your chips. So this one goes underneath our other e squared, plus 6e and minus 12 here. There are other ways of doing this, but I've just found through the years that if I take the opposite signs here and then I stack, I don't have to worry about, oh, am I adding this whole thing? Am I subtracting this whole thing? So you just look to the left, so you don't have to question it. So 5 minus 2, 3e squared, 3 plus 6 plus 9e, and negative 4 minus 12, negative 16. And that would be our answer. So that's 7-2. 7-3 is all about multiplying polynomials. Now remember, you could FOIL or box. Multiplying. So if you use FOIL, remember it stands for first, outer, inner, last, and that is the order in which you multiply your terms within your binomials. Let's go, how about good old x minus 4 times x plus 9. So you're going to multiply your first terms, x times x, x squared. X times plus 9, plus 9x. Inner, minus 4x. Last, minus 36. So that is your first two terms. That is your outer terms, your x and your 9. Your inner, your negative 4 and your x. That's your two inner terms of the quantities. And then your last is your negative 4 times 9. Combine your oi. With x squared plus 5x minus 36. As a quick check, negative 4 plus 9 is positive 5. Negative 4 times 9, negative 36. Now, if I were to box that, same problem. Your box size is determined on your polynomial. My kids know that as soon as you have a trinomial or more, you must use the box. I'm very picky about that. And not only that, but when you use the box method for multiplying anything greater than binomial, you want to put your largest polynomial on top. And then that way, you don't forget multiplying terms. It's very easy to see if you forgot to multiply something. That's why I don't like FOIL past binomials. So x times x, x squared, plus 9x. I'm going to kind of fly through this because, like I said, this is review. It's not by any means a lesson. I'm flying through it. So in a box, your like terms are diagonal with each other. And that would be your OI, so 9x minus 4x. That's your 5x. Your highest term is always in the top left, your lowest is always in the bottom right. X squared plus 5x minus 36 gets you the same answer. So remember, trinomial will be on top, smaller one down the side. 4 term, 5 term, 6 term, whatever it is, the biggest polynomial by its number of terms is across the top, smallest is down the side. And then once you get bigger than binomials, you'll have pairs of like terms. My kids expect to see that on tomorrow's test. And then section 7.4 was just our special cases. But we saw special cases twice this chapter. We saw it with multiplying, and then we saw it with factoring. Okay, so special cases. I'm just going to kind of throw some up here. These are special cases. This is the square of a binomial. This guy is called your difference of squares. This is the one that has, it's called the same thing whether you multiply or whether you factor. This is also a special case called the square of a binomial again. So these two are square of binomial. And when you multiply these out, you actually get a perfect square trinomial. So these two, square of binomial. And then this guy is a difference of squares. And the only thing different about them is their sign. Because if you take a look at these binomials, whoops, a plus b. Sorry about that. A minus b and a plus b. Remember, it could be a plus b and then a minus b as well. Because the only thing different about these two is their signs. So it's a difference of squares. And these two guys are called square of binomial. When you multiply them out, you get perfect square trinomial. And you multiply these the same exact way that you would any other binomials. They're just special because you're dealing with perfect squares. So on all of these, you will have a perfect square for when you multiply these guys out. C is going to be a perfect square, and B is going to be the square root of that doubled. Square root of that doubled. Let's go a minus 4 squared, which is the quantity a squared minus 8a plus 16. So the square root of 16 is 4. Technically, it's negative 4 as well, but we're going to get into that next 2 chapters. And then double that, you get negative 8. So anyways, you just multiply them out the same way, whether it's FOIL or box. I didn't show the multiplication here, just for time's sake. And that's all we had for 7.1 through 7.4. Hopefully this was a good enough review. If not, kids, send me a message. Remember, this was just a very quick review for very specific sections within our textbook. Okay. I hope the magic of Disney is with you guys on your tests tomorrow.